So we need to find out the directional derivative of this. To be able to address this problem, you need to be very familiar with partial differentiation, the product rule and chain rule. All the videos for that and explanations are in the description below. However, I'm not sure why you would be doing directional derivatives if you need a refresher on the product rule. Nevertheless, if you happen to be 13 years old doing this before the product rule, great. Go outside, touch some grass. Okay, what is the directional derivative? It is f xy, and then it is df dx xy, and df dy xy. So you're finding out basically a coordinate, a point, and you're going to have the df dx at this point, xy, which they've given you, and you'll plug that in. So the first thing that we need to do is find out what df dx is, and then eventually we'll plug the point into that differentiation to get a value. So for df dx, we have an x term, we have two x terms, so that means we have to use the product rule. So df dx is xy sine h x plus 2y plus y cos x plus 2y. Then we have to do df dy. Again, product rule, because there's a y there, so we need to do it for both. And that's going to be x cos x plus 2y plus 2xy sine h x plus 2y. So there we go. We've now got both our differentials for either of those. And then we would need to plug in the values of 1 and minus a half. However, we've got these pretty consistent sine h, x plus 2y, x plus 2y, x plus 2y, x plus 2y. So why don't we do sine h and plug in 1 and minus a half. So it's going to be 1 plus 2 minus a half, which is going to equal 0. And then we have cos 1 plus 2 minus a half, which equals 1. So that helps clear up a lot of this. So obviously, if we now plug in our values for df dx, your sine h's will equal 0, so that's all going to be 0. And then we'll have y, which is minus half. And then cos x plus 2y is 1. So therefore, df dx would be, df dx would equal minus a half. Now let's do df dy. So we know that now sine h here is 0, so that's all going to become 0. X is 1, cos is 1. So therefore, df dy would be 1. We're not completely done just yet. So this here, fxy, would be minus a half and 1. However, we need to now think about unit vectors. So we know that u is equal to a, b. So then the direction unit vector function would be what we've just found out, our directional derivative, and using the dot product of this unit vector. So it's going to be minus a half a times this plus 1 times b. Put a little dot there as well, which is going to be equal to minus 0.5 a plus b. So that there is the actual directional derivative of this function. I think a lot of people get to about this point or this point, and then they don't know how to just basically use the dot product. But all you're going to then do is multiply this by a singular unit vector, and you should get your answer.